Hi guys, this is Achyut. So we are going to be solving the today's LeetCode question, which is perfect squares. So we are given a number and we need to find the least number of perfect numbers that sum up to n. So the perfect square, as you know, let's say suppose if I take 2, 2 into 2 will be 4. So 4 is a perfect square. So there should not be any decimal after an integer point, and then if we multiply that number and then we'll get some number that is a perfect square. Let's say 1 is a perfect square, 1, 4 is a perfect square, 9 is a perfect square, and then 16 is a perfect square. See, 1 into 1 is 1, and then 2 into 2 is 4, and 3 into 3 is 9, and then 4 into 4 is 16. It will go like infinite. And then we are going to find the number of, we need to find least number of perfect squares that sum to n. So we need to find the least number of perfect square that sum up to n. So let's say you are given 1. Then the number will be least number of perfect square. Least number of perfect square that are required to make it as 1 is 1. So for 1 the answer is 1. And for 2 the answer will be 1 plus 1. Why? Because 1 is a perfect square and then one more 1 is a perfect square. If you take 3, then we are going to consider 1 plus 1 plus 1. And then for 4, it will be 2 into 2. So the answer will be 1. Why? Because 2 into 2 will be the perfect square. So like this, for all the perfect square, the answer will be 1. Why? Because if we multiply the square root of that number, we'll get the same number. So for all the perfect squares, the answer will be 1. And then one more thing we need to consider is when it is not a perfect square, then we need to make use of least number of perfect square that sum up to n. So let's say I have a number n. So then what will be the then what are the numbers we can take at last perfect square? So what I'm saying is, suppose let's say uh, there is one perfect square which is p1 plus p2 plus till pj, and then these perfect squares sum up to n. So what will be this pj is going to be? So 1 pj equal to some root j into root j. So we are going to multiply this root j to get this perfect square. So what are the different possibilities of pj and then rj? For pj, it can vary from n, and then it can vary from n minus 1. If we get n minus 1 as a perfect square, then we are going to consider that particular perfect square at that point, and then it can be till 1, right? So these are the different numbers pj can take. And then what about the pj should be perfect square? So instead of taking pj in the range, let's consider rj. What will be the range for rj? Let's say what is the maximum pj can take? it will be n. So what is the maximum Rj can take? It will be root of n, right? Suppose let's take a root of n plus 1. Then we are going to get Pj which will be greater than n. So the maximum range it can go till is root of n, and then it can go till 1. So this is going to be the range of Rj, which will be like at the last. And then for remaining thing, we are going to consider least number of perfect square, number of perfect square, squares of n minus Rj into Rj. So this will be the range for Rj. And then in this loop, we are for this particular Rj, there can be it can take the value from 1 to root of n. So we are going to consider Rj, and then whatever the previous results which we had stored here, we are going to get the result, and then we are going to add it to the current answer. So so if we are trying to build this solution, we are going to get the least number of perfect squares which we can get from n. So if we code this via recursion, and then we are going to optimize it further. So let's code this, and then you can understand it better. So let's take least number. This function is going to give us the answer. So and then we are going to write this function which will be least number. If you are doing the different, let's say if you are using the different language, then also you can see like the syntax might be different, but the logic behind what we are writing will be same. Like suppose if you are calling one function, and then suppose if you are writing the base condition, what will be the for loop? There will be a bit of change when you go from C++ to Java or C++ to Python, but the logic and the pseudocode and the intuition will be same for all the DSA questions. So focus on the logic and focus on the intuition. Don't focus on the language. You can code it in any language which you are familiar with. So what will be the base condition? Base condition is something like which will be the least valid input or low valid input or invalid input. Invalid input. So what will be the lowest valid input? Suppose let's say if we get n equal to 0, then what will be the least number which we get here? So the number of perfect squares used will be 0, right? So we are going to do the same thing. And then one more thing we should consider is, suppose if it is a perfect square, let's say if, let's take square root equal to sq, and then sqrt of number. If sq into sq is double equal to n. Let's say if it is a perfect square, then the number of perfect squares used is only one, right? Because as we have seen for 4, 9, 16, it will be only one. So we are going to return that case. And then what are the different possibilities which Rj can take? The root Rj. It can take from square root of n till 1. And whatever the least number used, we are going to use that number in this particular answer, and then we are going to return. So let's take temp answer equal to, what will be the, let's say for every case there will be n. The temporary answer will be n. Why? Because let's say you are given 5. we can divide it into 1 plus 1 plus 1 plus 1 plus 1. Like 5 digits we can divide using the perfect square of 1. So the temporary answer we can take it as n, and then for loop we are going to consider I equal to square root, and then I should be greater than or equal to 1 and I minus minus. So these are the different values I can take, like RJ can take, and then we are going to store the temporary answer equal to minimum of temp answer, and then we are going to consider the case where we will be using I as the perfect square at the end. So this will be n minus I into I. So this is going to give us the one of the possibility, and the numbers are used. And then we are going to return temporary answer. So this is a recursive solution, but some of the times let's run this. So if we use it for bigger cases, let's say the constraint is still 10 power 4. Suppose let's say you had calculated the answer for n of 12, and when this recursive solution is called, even though if you had calculated this answer previously, we are going to do the computation again. So this is going to run again. So that's why the solution might exceed the time limit. The solution is correct, but the time complexity will be higher. What is it? Yeah, this is going to be int. So that's why we need to, it will exceed the time limit. So that's why we need to use the dynamic programming. Like suppose when the problem is already solved, you need to store it somewhere so that you can use when you come up with the same problem. See, we got time limit exceeded because when the solution is higher, like the input exceeds, and then we are going to call the function again and again, and then we are going to solve the problem again and again. So we need to use DP for this. So let's take the DP10. This is the maximum, and then we are going to consider, like, we are going to set DP to -1, so that if we see it is -1, then we can say that the problem is not solved. So you can solve it again and then return the answer. So here we are going to check if DP of n not equal to -1, then the problem is already solved. So we don't need to do again computation. Whatever the solution which is stored in DP of n, we can just return that. And then after calculating the solution, let's say temporary answer, you got some answer. Then we are going to store it in DP of n, and then we are going to return the same answer. So whenever we get again called with DP of n, so we are going to see it is not equal to -1, and then we are going to return DP of n. Yeah, that's the logic behind this, why we are going to use the extra space. Because whenever the problem is solved, we are going to consider that in the DP, and then we'll return the same answer which is already solved. Yeah, let's submit this. Yeah, it is accepted. So if you see the like time complexity, we are going to be called like every digit. For every digit, this might be going to be called, and then we are going through square root of n times. So the time complexity for this is going to be big O of n into square root of n. This is going to be the time complexity. And then space complexity is going to be big of n. Why? Because we are using dp of 1 10 power 4, which is like the constant. So it will be big O of n. Yeah, that's all for this video. Thanks for watching the video. If you like the video, like the video. If you doesn't like the video, please dislike it. Thanks.